What's up, everyone? How's it going? Cool. You guys liking PyBay so far? Hopefully. Sweet, sweet, good. Glad everyone's having a good time. So I just want to mention one thing before we get started, or actually two things. I lied. Great way to start off a talk. But I want to officially rename this talk last second. I know you guys are here because you love security, but if you're anything like me, I was writing this talk last week, right? And I know it was an hour talk slot. And so at the end of me putting the slides together, I threw this little stick figure face at the bottom because I figured if you're anything like me, you're probably sitting in the audience thinking, does this fucking guy really think he's going to be able to teach me everything I ever want to know about authentication in just 60 minutes? Which is why I'm officially renaming this to almost everything you ever want to know about authentication in Python. Because I realized I can't squeeze it on there. I'll get most of it. I'm trying to go for 90% here, so you can live with it, basically. The other thing is I'm pretty casual, so if you get stuck somewhere, you have a question or you don't understand something, raise your hand. I'll call on you, shout it out. I'll repeat it so everyone can hear it, and we'll make sure everyone's on the same level, okay? So this whole thing is geared for beginners all the way up to advanced developers. It's going to start slow and get progressively more difficult, so bear with me, all right? And finally, this is my Twitter handle, so if you want to tweet hate or love or whatever you want, that's where you can do it. A little bit about me. My name is Randall Degges. I run the developer advocacy program at this company called Okta. We are an API company, and we store people's user accounts. We encrypt personal information. We do HIPAA compliance and all sorts of security-related things. I'm also a big open source developer. I've been writing code since I was a very young kid. Security has always been my interest. I do a lot of crypto work in the community. I do some core OS development stuff as well. And what I'm here to talk with you guys about today is like the journey that happens every time you go to a web browser and you go to the login page and you type in an email and password and you hit login. Like what actually happens behind the scenes to make that work? So I think that's a really interesting story, which is why I'm giving this talk to you guys today. And my goal is to really make sure that you understand the entire process from start to finish, okay? That's my goal. So I'm gonna step you through, with code, the entire process from start to finish. You're not gonna miss out on anything, literally nothing. And again, don't forget, ask questions if you get stuck. Now, the only way to do this, or the way I've found to do this, is to build an app in real time and show you exactly how it works. So this is what we're gonna build. So a really simple web app that's a registration page, a login page, and a dashboard page. Because without those three things, this would be a really shitty talk. That's why we're doing it that way. Now, like I said before, we're gonna go through the entire thing step by step. So real quick, I'm only gonna make two assumptions about you this whole talk. So this is what they are. So A, you know what Python is and a little bit about how to use it. I'm pretty sure that's a safe bet since we're at PyBay. The second assumption I'm going to make is that you're willing to install MongoDB on your computer. Now, I know that's going to really annoy some of you really bad. If I saw this in a talk, I would probably say, wow, Randall is probably a noob. He likes MongoDB, and like that's sort of a shitty database. No judgment. But here's the thing. I'm actually a Postgres developer. I really like Postgres. But for purposes of this talk, I'm showing Mongo because it fits better onto slides. That's it. Okay? Now, we're going to build this web app in Flask. How many of you are familiar with Flask? Raise your hands. Okay, great. So everyone has a basic understanding of it. Flask is a very minimal Python web framework. It's pretty awesome for showing examples like this. The reason I'm choosing Flask for this talk is because if I were to show you how this works in Django, it'd be like one line of code and you would all just walk out of here in 10 seconds. So that's why we're going this route. So pip install Flask is a requirement. The next thing we want to do is we're going to build this really simple app through the course of this talk, and we're only going to have one server file. It's going to be called server.py. It's going to hold all of our Python code. Then we're going to have some basic HTML templates that are just going to render some really simple design things. Now keep in mind, I'm not a designer. So the first thing I'm going to do, because I hate design, is just get that out of the way real fast, all right? Now, how many of you in here are familiar with Python templating for HTML? Raise your hands. Okay. So quick refresher course for those of you who may not be. This is an HTML page. Pretty basic HTML with a few subtle things, right? This thing right here is a variable. I'm inserting a variable into this template called title. I could insert a string there like home or login or register. It will render in the HTML. This thing down here is also a variable, except instead of inserting a string there, I'm going to insert another block of code. So everything between these, the block body and the end block tag, I'm going to insert some code there. Now, if you notice, this template is called base.html. So every page you're about to see, the actual design stuff, is going to use this template and insert code into different parts of this page. Everyone following so far? Okay, fantastic. Now, let's take a look at our index page. This is going to be the home page of this really simple web app. And what you're going to notice in here is the first thing at the top is it says extends base.html. This is a Jinja template. That's what this language is called. It's a subset of HTML, or superset of HTML. And what this means is that all the other things you see here inside of those, squiggly % tags are going to be inserted into the template on this previous page. Is this starting to make sense? Great. So when we say set title equals home, that's going to go back and go into the home variable there. Yes? The name of this language is called Jinja, Jinja, the number 2, Jinja 2, technically. Good question. Now, everything inside of this body tag here, this block body, this HTML is just going to get inserted into the previous template right there. So if we were to display this index.html page, all those substitutions will take place, and we have this nice little home page rendered. Everyone good? This is important. Okay, fantastic. I'm telling you, it's going to speed up significantly, so bear with me. Now, here's the registration page. This is a really basic HTML form. That's all we're looking at here, right? There's a form. It takes in 4 pieces of information: a first name, a last name, an email, and a password. That's your pretty standard, typical registration page, right? Nod your heads. Okay, great. Now, we got a login page. And this is almost exactly the same as before, except there's only 2 things it cares about: an email and a password. Again, pretty straightforward, right? Head shaking. Okay, cool. Then finally, we have this dashboard page. And this is what the user is going to log into. And all it says is, hey, you've logged into the dashboard. Welcome. Again, makes sense. Fantastic. Whew. All right, done with the design part. That was the hardest part of this whole thing. Now, a lot of people, how many of you have heard this thing where people say security is hard and you should never implement it yourself? Anyone hear that? Okay, those people are liars. Security is really easy, so watch. This is going to be fun. Now, okay, I jumped ahead a little bit. We'll get there. But here's our server.py, right? So we have some HTML templates. Now we, at the bare minimum, need to render them when the user visits the register URL or the login URL, right? And so how are we going to do that? Well, this is the most minimal possible Flask app you can build. Real quick description. We're going to import some objects that we need and some functions. We're going to define our web app in Flask. This is basic web app syntax. We're going to define some view functions. Now, all these functions here are just basically called a view. And what they do is, what this means is like this function login will run if the user visits this URL /login, okay? And what you see in the body here is this function is just going to return a template called login.html that we defined earlier. That function render template is just going to render it, to put all those variables in there like I went through with you before, and just show it on the screen. Pretty simple stuff. Now, there is one exception here. The one important exception is that you notice that some of these guys say app.route/register, and they have methods and an array in there afterwards, right? Do all of you know what that is? Raise your hand if you're confused. Switch it up on you, see? Okay, good. So the way this works is browsers usually make 2 types of requests. They make a GET request and a POST request. A GET request says, hey, give me some information. I want to see something. A POST request is when a browser says, hey, website, I want to send you some information. I want you to use it and do something cool. That's the idea behind it. Now, by default, when you set up this app.route thing and tell Flask that, hey, if a user visits this URL, I want you to run this function will only run and render things based on a GET request. If you wanted to also support a POST request, you need to be explicit about that, as you can see here. I'm passing in and telling it specifically to support both types of requests. Now, trivia fact, do any of you know why Flask syntax requires you to specify both types of requests in that parameter there? Okay, I'll answer it myself. It's because in Python, one of the principles is it's always better to be explicit than implicit. So we're explicitly calling out that we want it to support both types of requests. Did I lose anyone? We're good, right? Okay. Now, here we go. So when we want to run this and test everything out, you run your Flask app by defining the name of the file in which your Flask app resides, server.py in this case, and then you say flask run on the command line. This is going to start up a web server locally on port 5000 by default. And if you go and visit the web pages, you'll actually see these are what the pages look like. I just screenshotted it in my browser. So as you can tell, I'm no designer, obviously. Now we're going to get into security stuff. Now, a lot of people think security begins at like password hashing and cryptography or whatever. Those people are crazy because security starts with an HTML form. So I can't do a security talk, a proper one, without explaining how HTML forms work because that would be a horrible travesty to the security community. So let's talk about that. Now, all of you know HTML. It's pretty basic. If you have an HTML form, it's collecting inputs to send to a web server, right? And I mentioned before that the method is really important, right? So a post method means you're sending data to a web server. A get method means you're receiving data from a web server. Now, whenever, I'm just going to make a blanket statement, whenever you're sending information to a web server, you almost always want to use a post request, especially when you're dealing with sensitive information like people's first name, last name, email, password, and things like that, okay? I'll explain why in a moment. But this is the way our registration page looks right now. Just has this registration form embedded inside of it. Now, with all that said, we have this registration page. We have it running in this local Flask app. So what do we need to do to actually view the information from the form that the user is submitting to our web server? That's what we're going to look at here. So if we go back to our registration view from earlier, what we can do now is we can add this little conditional here. We basically say, hey, if the method of the request is a post request, then instead of just rendering the registration page, we're going to return some data. The data we're going to return is going to be this thing called request.form. Now, this is what that is. So what I'm showing you here is imagine if I have this registration page open. I type in my first name, my last name, my email, my password into the form, and I hit submit. That information is transmitted to this Python code in this function running with Flask. Flask is going to put that information into a Python dictionary and assign it to a variable called request.form. And this function called JSONify is just going to display that information back to me in my web browser as JSON data. You guys following? Am I losing anyone? Don't be ashamed. It's all good. Okay, great. So we're making progress here. So now we can see the data that is being sent to us. So we're almost done. But we have to store it somewhere. So we can't have a site that remembers who people are and creates users and stuff unless we can store their information in some sort of database. And now you guys are about to hate me, but this is why we need to use Mongo, because it's going to make this a really quick example. Now, MongoDB is very similar to relational databases. It's just much sillier and easier to mess around with, basically. Now, quick introduction. So if you're using MongoDB, there's only a few things you need to care about. One is how do you create a database? The way you do that is you use the use command. So if you say use test inside of Mongo, it's going to create a database called test if one does not already exist and put you inside of it. In Mongo, instead of tables inside of a database, you have something called a collection. And so the way you view all the tables, aka collections, is you simply say show collections. Everyone following? Making sense? Great. And the way you insert a row into a table, or what Mongo calls a document into a collection, is you say db.collection name, which in this case is users, .insert, and then you just give it some random JSON data. So what I'm doing here is I'm showing you how to actually store a user in the database directly using the command line. And what happens then is if we were to store some data in our collection, in our Mongo database, then what we can do is to view all the things that we've stored, we say db.users.find, and it just lists everything we've ever stored out. It's like a select star in a relational database. Everyone good so far? Great. Now the one thing I want to point out, I created this user. As you can see, there's a special property called _ID, which is assigned to a, not random, but a long-looking number object here, okay? Mongo will generate an ID for everything we store in the database by default. Just remember that. Now, in order to actually hook this into our Python app, right, we need to use some libraries because otherwise this is going to be a 5-hour talk. And we could do that, but you guys have families and want to go home and do other stuff, so we're not going to. Now, the library I like to use for this is flask-pymongo. It provides this very simple API that you see before you. And all you need to do is in your server.py, you tell the library via this configuration variable what database name you want to use inside of MongoDB. So just like a relational database, you can have 100 databases if you want, 1,000, however many you want. And finally, you initialize it with this line right here. It's called a Flask extension. And when you pass your Flask application into the PyMongo constructor, behind the scenes, it's going to connect to the database, validate all the settings, create a connection pool, sort of handle all that nasty stuff for you. Everyone good still? Cool. So now we have our database set up. Let's actually use it to store a user when the user signs up through our registration page. So what we're going to do here is this. Going back to our registration view, we're going to add this line right here. We're going to say mongo.db.users.insert_1, which tells it to insert one item into the database. And then we're going to pass in this data here, request.form, and I'm converting it to a dictionary, but you can ignore that. And if you remember from before, that request.form value is whatever information has been submitted to us through the HTML form on the registration page. So if I were to type my first name, last name, email, and password in there, I would then be inserting that directly into MongoDB. Does that make sense? Great. And then finally, I'm using some new functions down here, redirect and URL for. But basically, all these are going to do, sorry for the distraction there, but all these are going to do is say, hey, once the user's been inserted into the database, we're going to redirect the user to the dashboard page. That's all we're going to do. Sound good? Cool. So now, let's talk about login. How do we authenticate a user? So we've been able to successfully register them on our site, but how do we authenticate them? And this is basically it. It's quite simple. So in our login code, we're going to find a user from the database. So instead of inserting one, we're going to use this command called find one, just like that. And what we're saying here is we're telling Mongo we want to find a user inside of this users collection whose email address is the same as the email address that's been submitted to us from the login form on the login page. Making sense? And then finally what we're going to do is we're going to compare the password from the database to the password the user supplied in the login form, make sure they're the same, because we don't want someone to log in with an invalid password, right? Cool. And then we're just going to redirect the user to the dashboard page, assuming everything goes well. Now you might, oh yes, questions? Yeah. Mm-hmm. So that is going to have a form in HTML, right? And so when you type in the information and you hit login, that is sending, the browser is sending a post request to the login page in Flask. Now, because this login route here, /login, has a post request supported, it's going to come into this function, it's going to check to make sure the method is post, which it is. It's going to run this code, which takes us to where we are right now. Great question. Yes? So I'm explicitly not showing error handling here, just to keep it brief. But yeah, in general, what you would do is you'd have error checking here. So if the user can't be found in the database, you say, hey, invalid email password, et cetera. Of course. Oh, yeah. Oh, that's fine. I mean, you can just modify this example. It doesn't have to be verbatim, right? So let's say you don't want to accept first name, last name. You can do whatever you want, right? Just for the demo. Now, let's talk about sessions. So far, we've actually built a site. It technically works, although it's pretty shitty, and we'll talk about why, right? But let's talk about sessions, because this shit is pretty interesting. You guys got to get hyped up. It's too quiet in here. Okay. So here's the premise of sessions, right? So if you are building a website back in oh my God, whatever, fuck it. If you're building a website, HTTP is a stateless protocol. It doesn't remember shit. It's horrible, right? And so if you had to go to a website and every single page you want to view, you had to continuously resupply your username and your password over and over again, you would just never use websites, right? That'd be horrible. And so the idea of sessions are to avoid that, to make HTTP remember something, remember who you are. So sessions are just a hack that all of us use to force it to be a stateful protocol, to remember stuff about you. Now, the idea of sessions specifically is that when you log into a website, the website is going to validate your password, your email, stuff like that, and then it's going to generate some ID for you. It's usually called a session ID. It could be any sort of thing, though. That identifier is going to, the website's basically going to tell the browser, hey, remember this ID, I'm assigning it to you. And then from now on, browser, every time you go and visit another page on my website, why don't you send this ID back to me with every request you make? That way I can remember who you are. I'll just read this ID and I'll remember, oh yeah, that's Randall. That's the idea of a session. Making sense? Cool. Now, the mechanism by which sessions work is typically through this thing called cookies, which I'm sure you all have heard of. I'm sure most people know how they work. But with cookies, what happens is when you authenticate to a website, the website generates, a cookie. And that cookie contains the user ID or session ID or whatever you want to call it. And it tells the browser to remember that thing inside of a cookie. And so browsers, when they store a cookie for a website, they just automatically send that information back to the website on every request. That's how cookies work. Sound good? Sweet. Now, before I explain how cookies work, we need to talk about one thing real quick. So in HTTP, there's an HTTP request, which is where your browser sends a request to a web server to say, hey, give me something. Then there's the response, where the web server sends a response back to the browser, right? Those things have the same structure. They have two components for a request and a response. The first are called HTTP headers. These are just key value information about a request. They're just metadata, okay? So a popular one is the user agent header. So every browser in the world, when you make a request to a web page, it will automatically send this value, user agent, just a string, to the website. That way the website can know what browser you're using. Standard. The second thing you should know is the body of the request is where all the fun stuff happens, okay? So if you go to facebook.com and it sends back all the pretty newsfeed stuff, that HTML is always in the body of the request, okay? That's where the good stuff is. Only metadata is stored in the headers. Now, with that in mind, let's talk about cookies. So how are cookies created? How can a website tell a browser to actually remember something? The way it accomplishes this is via headers. Specifically, a header called set-cookie. So what you see here is an actual cookie called an actual cookie called session, whose value is 1, 2, 3, 4, 5. This is a real syntax. If you were to create this header, send it to a browser, the browser would remember the value, session equals 1, 2, 3, 4, 5. So for you guys, the way I like to put it is cookies and this stuff right here, it's just like using a variable. You just tell the browser to remember some variables for you. Now, if you want to remember multiple things, you use this syntax. You just tack a semicolon on the end, and bam, everything just magically works. You can store multiple variables. Makes sense, right? Pretty basic. And the same is true vice versa. So once a browser has remembered these variables, the way that it sends them back to you automatically is it just adds a header to all of its requests called cookie. And it just echoes the data right back to you. So every time once that cookie's been set, it's just going to go ahead and resend those to you every single request it makes. That's how the statefulness is created. This is the premise by which all the rest of all web authentication stuff works. Cool? Okay. So now let's take a quick look at how we actually use sessions and cookies inside of Flask, all right? So luckily, it's quite easy. The only thing you need to know is that Flask, when it creates these cookies for us and handles these web sessions, keeping people logged in over time, it does something called cryptographic signing, which I'll explain later. But just know that these things are cryptographically signed for now, and keep that in mind. Now, a prerequisite to make this work is you need to specify a long random string called a secret key that Flask will use to cryptographically sign all of the cookies you create, okay? That's just a requirement. This should be a long random string, something that you never push to GitHub, something you never tell people, something that only exists on your web servers, and it keeps things secure, it keeps your cookies secure. Just think of it that way. Now, if we go back to our logging code from before, the way we implement statefulness, like the way we actually implement sessions, have it remember stuff for us, is we only add a single line of code. That's it. So once we check a user's password to make sure it's valid, we're just going to modify this session object like a dictionary, add a variable called ID, and set it equal to the user's ID, which was created by MongoDB. Remember that underscore ID variable from before? This is where it comes into play. So we're going to use that as the unique identifier to identify a user from. Everyone good? Any questions? Good? Okay, sweet. Now, if you actually test this out, I went to Chrome Inspector, I logged in, I went and I viewed from the network tab, exactly what response was sent back to my website. So this is how it looks. Once you log in, you're going to get a response cookie created called session. Okay, Flask is creating this for us automatically. The value of that cookie is this long random looking string here. Behind the scenes, that actually says ID equals, the user ID. So it is just cryptographically signing that information, which makes it a little bit jarbled. People can't hack it or mess with it, basically. They can decrypt it, by the way. It's not encrypted, but we'll talk about that later. But that's the premise here, okay? So this is what it looks like in the real world in Chrome. Okay. Now, we've just modified our registration page, right? So it stores someone's information in a session. Now let's talk about our dashboard page. So our dashboard page right now, if you visit it, anyone can visit it. It's totally public. We need to add some security there. We need to make sure someone's actually logged in order to see this thing work. And the way we do that is by using sessions again. So the first thing we do is we basically just do a simple condition where we say, hey, if that variable ID is not found inside of the session, then we're basically going to tell the user, whoops, oh, I missed the cool animation, damn. Well, we're going to tell the user to go back to the login page. We're going to redirect them to the login page. If there's no ID for this person, we know they're not logged in, so we send them to the login page. Otherwise, if they have an ID, we're going to try to load their information out of MongoDB so we know who they are. So we're going to talk to MongoDB, and we're going to query for their information. But this time, instead of querying for their information by an email address, we're going to search for it by their ID value that was stored in the cookie. Now, you see here I'm typecasting this into this object called object ID. That's a MongoDB specific thing. You can ignore it. Basically, we're just searching for the user by an ID. And then finally, if everything works well and it's a happy path, then finally we will show the user the dashboard page down there. Everyone following? Great. So now, let's talk about storing passwords. So we've got the basic session management stuff done, right? But now we have to upgrade our shit because it's pretty bad. So a lot of you more advanced people are sitting here saying, wow, Randall's a noob, because right now all of my user information is stored in a database in plain text, right? It's pretty horrible. So my password is just sitting in the database, clearly accessible to anyone on the internet. MongoDB is also not a particularly secure database, so this is doubly bad. Now, let's fix that. The way we fix that is with password hashing. Now, I know most of you have heard of password hashing before. You probably have a good idea of what it is. But today, we're going to upgrade that knowledge just a little bit. There's two main things you need to know about password hashing, okay? Three main things. The first thing is that password hashing is when you take a password and you convert it into a long, random-looking string. That's the first thing, okay? The two principles you need to know about that, though, are this. The same password always generates the same hash. That's the first rule. So if you take the hash of my password, which is just woot, and you get a long, random-looking string, and then you take the hash of that woot word again, you get the same long, random-looking string. Make sense? If I were to put a different password through this function, though, I would get a totally different long, random-looking string. Which brings me to the next point that you need to remember. That once you have a hash, you can never go back. You can never decrypt it, so to speak, into the original password. It's called a one-way function because once you put something through it and you have this long, random-looking string, there's no way to recover the original password. There's no way to hack it, right? Okay, so right now, all of you know more than 99% of Verizon engineers, so congratulations. Okay. Sorry if you work at Verizon, but you deserve that. So anyways, so now let's talk about hashing, right? These are hashing algorithms. These are the names of them. I know most of you are familiar with it. It's probably no surprise to you that I'm showing these things here. They start weak. They get progressively stronger down this list. Now, I talk to people about password hashing a lot. I've given a lot of lectures on it and stuff. And one thing I always get questions from are people that are like, hey, what about this other algorithm that isn't on this list? Which is why I put together this nice key value chart. So if it's not on this list, it's bad and you shouldn't use it. And if it's one of these couple things up there, it's bad and you shouldn't use it. As a matter of fact, unless it's one of these three things, it's bad and you should not use it. That's the rule, okay? Now, I'm going to quickly explain why these are sort of the best things to use. Now, bcrypt is what I recommend people use today. It's a hashing algorithm. It was created in 1996 by a famous cryptographer named Bruce Schneier. He's also the author of sort of modern cryptography. His book, Practical Cryptography, is recommended reading. I highly recommend it if you're interested in security. It's fantastic. It's been well audited, and it's a great function. scrypt was created in 2006 by another famous security researcher named Colin Percival. He's the head of the FreeBSD security project. He works on a lot of really interesting security tools. He runs an online backup service. All around interesting guy. It is significantly more secure than bcrypt. The reason I'm telling you not to use it is it hasn't been around as long, it hasn't been as well vetted, okay? And then finally, 2 years ago, this new hashing algorithm called Argon2 came out. I actually did an interview with its author, Jean-Philippe Ameson, and his team, and it is quite possibly the strongest possible type of password hash that is available today. I can get into the details why at the end of this talk if you're interested, but there is currently a process going through the National Institute of Standards Technology, NIST, where Argon2 is going to become the new recommended password hashing standard. So sometime in the next 5 to 10 years, those sort of things move slow, Argon2 will become the de facto hashing algorithm. Question? Yes? I would definitely not recommend SHA-3. Yeah. I can talk about specifics after if you want. Noah, you want to say something? No, that's garbage. I'm sorry. So he's asking about this algorithm called PBK-DF2, which Django and a lot of other web frameworks use, and I'm just telling you, no, don't use it. Now, I'll get into why afterwards if you want. We can have a discussion. But the pseudocode for this, the way this works in general, is you have a string, which is your password, right? Makes sense. You want to make it more secure, so you create a hash by running it through this function. And if you look at that hash, it's just a long, random-looking string. This is the way pretty much all hashing things work at a high level. And let's take a look at how it actually looks in our registration code. So, first thing we need to do, install 2 libraries, bcrypt and passlib. These are what I sort of prefer to use to make this stuff work nicely. Now, what I did is I rewrote part of our registration code here, and I'll explain it a little, piece by piece. The first thing I do is I take all the user data that's been submitted to us from the registration form in the HTML, right? I convert it to a dictionary. This makes it easy to work with. Then what I do is I take the password inside of there, the plain text password, and I'm going to override that field. And I'm going to override it with a bcrypt hash of that field. So I'm taking the password, I'm hashing it, and I'm overriding the plain text password. And then finally, I just go about the rest of my day doing the same thing I did before, where I insert the user data into the database, and now everything's great, because guess what? The password is now stored in a hashed format in the database. It's pretty cool. But now we have a huge problem, right? Because if you're following along step by step, which obviously none of you can type that fast, probably, but assume you could, right? Our login functionality is totally broken, because now when we try to log in, we're comparing a password hash to a plain text password, and that's not going to ever match. So we need to upgrade our login stuff, basically. And the way we do that is just like that. So instead of comparing the passwords with equals equals, we instead just call this function bcrypt.verify. We give it the plain text password and the hashed password, and behind the scenes, it handles the comparison checks for us. Makes sense, right? Awesome. And now, if we go into MongoDB, the more experienced ones in here who were hating on me before are like, okay, maybe Randall's not so bad. I see it's actually stored rather secure. Okay. Now, how many of you in here are looking for a job? Throw your hands up. Okay, cool. So easy job right here for you. Pay attention. This is going to be valuable. Write this website down. Go to this website. Check it out. The guy who maintains it basically publicly shames companies that store your passwords in plain text. It's pretty funny. So he keeps the log. He takes screenshots. He talks about it. Easy way to get a job, say, hey, I just saw this fun security talk, and I'd love to work for you and fix your security issues, which you clearly have. Okay? Easy job. And also, if you're not looking for a job, you can just go there and join in the fun. It's pretty fun. So go for it. All right, so up until this point, we did the bare minimum, right? Now we're just going to get slightly above the bare minimum and do some refactoring, because I am all about that shit. So first thing we want to do, we want to improve our user loading, is what I'm going to call this. I don't know if that's the right technical term, but the way that we access a user object in the rest of our code base. Because right now what we're doing is we're checking for session IDs, we're talking to MongoDB, we're doing all this logic in our dashboard page and our registration page and all these different places, right? And that's sort of annoying. Because if this website had more than just a dashboard page that needed to be protected, then we would be shit out of luck, basically, right? Excuse my language. Now, what we're going to do is we're going to write this function called load user. And what we do is we check to see if, oh, by the way, this app.beforeRequest thing, what this means is that every time a request comes into our website, Flask is going to run this function before any of our other functions. So before the dashboard code runs, before anything else, all right? So what we're going to do is we're going to take advantage of that. And we're going to say, well, we're going to look to see if a user's logged in or not before anything else happens. If they are logged in, if there's an ID there, we're going to find the user in the database. We're going to load them. Then we're going to delete their password field. Now, the reason I'm deleting the password field is because the odds of you accidentally printing a user password to the console or showing it to someone in a template on accident is pretty high. So what I like to do is just delete that data altogether. Now, a more secure way of doing what I'm doing here by deleting that password field is actually to just not have MongoDB return it in the query at all. I'm leaving that out of this slide, just FYI, because it's a much longer command, but hopefully that makes sense. And finally, here's the magic part. We're assigning this variable here called g.user to be our user object. Up top, we're defining a global variable, which is called user, which is using this thing built into Flask called local proxy. All it's going to do is give us the ability to reference this global variable called user in any of our functions, and that will have our fully loaded user information inside of it. Okay? Oh, and I was supposed to point this out, I apologize. But there you go, fun animations. Question, yes? It's because if you want to, like, you never want to leak sensitive information. So even if a password is hashed, you don't want to post it publicly on a website or anything, because someone can try to brute force it. They can try over and over and over again and see if they can eventually guess it. Question, yes? That's correct. We're going to talk about that. Yeah, the password is being transmitted in plain text right now. Okay. Now the next thing we want to do, this is still part of refactoring, is define a decorator called login required. This is just going to make it easier for us to require someone to be logged in to view a page on our site, like the dashboard page or the console page or whatever you want to call it. And so all we do here, I'm not going to walk through the concept of decorators, but basically, if there's no user logged in, then we're going to tell the user, get out of here. That's it. Because they're not logged in, so they can't access the page. And then if they are logged in and they can access the page, we're just going to keep doing whatever they were trying to do anyways, like visit the dashboard or whatever they wanted to do. And so the way this looks is when we refactor things, we go back to our dashboard code, and this is what it looks like all cleaned up. We add this login required decorator onto our function. That forces the user to be logged in. Then inside of our function, we are now able to access the user's information by just saying user, it's a user object, dot whatever, user.firstname, user.email, user.lastname, etc. Because of those two things we just did. Pretty decent, right? Not totally horrible. Question? I'm hearing stuff? No? Okay. Finally, let's talk about CSRF, so cross-site request forgery, real quick. Now, the best way I like to explain this to people, because I know you're not all familiar with it, is through example. Let's say you have a bank account online, and there's a withdrawal page where you can send money to someone. And you're logged into your bank account, right? This is what the page looks like. Now, what happens if someone sends you a link that looks like this? To bank.com/withdrawal, in query parameters, they say, oh, $1 million, I want to transfer it to my account. And they tricked you into clicking that link. Well, what's going to happen is you're just going to lose $1 million most likely, because they didn't implement CSRF protection. So what's happening is you've been tricked into going to this link and pre-filling those form fields with data, and you didn't realize you were doing that because you were already logged in. Making sense a little bit? Okay, cool. The way we defeat this in web security is through a pattern called CSRF prevention with tokens. This is the only way to prevent this. What happens is, let's go through a typical login flow. You go to the login page of a website. The web server sends you back a login page with an HTML form to log in, right? It asks for your email, it asks for your password, but it also is going to embed a special token inside of a hidden input field on that page. Then the server is also going to set that same token in a cookie, which goes to your website. And the browser is going to store that CSRF token as a cookie. Then what's going to happen is when the user types in their email and password and hits submit, their email, password, and this token and the cookie are all going to be submitted back to the website. Then we're going to do some logic on the website to check to see if the cookie value and the hidden input value are the same. If they're the same, then we know that the user has visited this page before typing information and hitting submit. If they're not the same, it means the user was tricked into clicking this link and submitting a form without knowing they were doing it. And so the server will just reject the request. What is happening in this example? This is how we implement CSRF protection. Now, what do we do here? Well, basically, we have a form, and this is how we do it. We plug in this hidden input field into all of our forms that are sending data to our website. We give it a name, CSRF token, and we put this variable value inside of it. There's a library that does this. The library is called flask-CSRF, but it's spelled funny, CSRF. And this is all you have to do to implement it. You have these 2 lines of code that will handle all the token generation, all the verification, everything to prevent you from having that nasty stuff happen. And that's pretty cool, I think. All right, so real quick, let's talk about some security best practices. So we went through the implementation stuff. Let's go over some of the high-level stuff. Always use SSL. This is what this gentleman over here was saying earlier. He said, yeah, we're sending the password in plain text from my browser to my web server so someone can see that password on the Starbucks network, for instance, right, on Wi-Fi. The answer is yeah, unless you're using SSL. So any website you build ever, anything that does any sort of login is absolutely mandatory to use SSL for it. That is the only way to keep your personal information secure, no matter what you're building, okay? So it's a requirement. The next thing you should know is that cookies can be tuned for some security purposes as well. And there's a few options you should know about, which you should always enable. The first of which is called HTTP only, up at the top. This should always be enabled. So how many of you know what the most dangerous thing in the world today actually is? Raise your hand. Noah. JavaScript. That's goddamn right. It's the most dangerous shit in the whole universe. It's bad. If you run it, like, bad things usually happen. So by turning HTTP only on, what happens is you tell the browser, hey, browser, I'm giving you this cookie. You're not allowed to let any JavaScript code access it ever, under any circumstance. And that reduces a whole bunch of problems. The next thing we have is this flag called secure. What that means is you tell the browser, hey, I won't even send a cookie to you unless we're talking to each other over SSL. That guarantees at least some level of end-to-end security there. And then finally, another important thing to remember is the session lifetime. Like, when you set a cookie, when someone logs into your site, how long should they stay logged in? 30 minutes, an hour, a day, a week, a month, a year? It really depends on what you're building, but you should know what that value is, and you should explicitly set it, okay? And also, you don't want to roll your own. So I'm walking you through this to help you understand it, but in reality, it's a very bad idea to do this yourself. You should use an open source library instead. So here are some of my favorites. Flask login, Flask security. These are specifically for Flask developers, obviously. The company I work for, Okta, we also do a very similar thing to this, so you can use that as well. I have some resources online you can go check out. And also, if you want to hit me up, this is my Twitter. This is my company Twitter, so if you're interested in more security stuff, we do a lot of that at Okta. And finally, I just want to make one announcement. They are doing a job fair out there in a second, so you guys are officially excused. But if you want to stay in for a special bonus section, I'm going to go for 5 more minutes, if you want. But no pressure. You should definitely leave if you want to. And the reason I would like to do that is because how many of you are interested in token authentication? Yeah, that's sort of what I thought. So I have that all packed into the next 5 minutes if you want to stick around. But yeah, other than that, thank you. So please run along if you need to. No one's leaving. This is crazy. Okay. All right. Okay, you guys. So bonus section. The reason why I don't talk about token authentication in this talk at all is because it's absolutely garbage. It's horrible. And I could talk about it all day. I've actually given a separate talk, which is like a full hour just about all the reasons it sucks. But I figured I would condense it into a very short part at the end here for those of you that are interested in learning more about that. So this encompasses everything from JSON web tokens, token authentication, all the new latest and greatest bleeding edge stuff. It's all just absolutely horrible, and I'm going to explain why. So before I can basically shit talk it for a few minutes here, we need to explain what it is. So when most people talk about token authentication, what they're actually talking about are JWTs, aka JSON web tokens. Raise your hand if you've heard of these or used these before. Okay, great. Raise your hand if you know all about them. Okay, this is going to be really useful then. So JSON Web Tokens, they're JSON data, okay? They're cryptographically signed. I'm going to get to that in a minute. They're not fancy. That's important. Remember that. And they're not encrypted usually. Make sense? All right. That's correct, usually. Now, let's talk about what is cryptographic signing. What is a cryptographic signature? What the hell does it actually mean, right? I mentioned that a few times, but it's a useless thing to know what a word is and have no context for it, right? So let's say I write you a letter, and I sign my name at the bottom. When you receive that letter, you see my signature, and it says Randall, and you say, oh, I know Randall. I know his signature. I know that he wrote all the rest of the things on this page, so I trust it, okay? It's my way of identifying myself for some information I'm passing along to someone. Make sense? That's exactly what a cryptographic signature is, except for computers. Now, oh, and there's the animation. Now, what do they actually do? And this is important. They prove that some data was generated by someone else. That is the sole purpose of a JSON Web Token, okay? The best example of this I can give you is your driver's license or your passport, all right? That is issued by the US government. They are signing it by giving it to you in this format with like the little stamps on there and everything. That is their cryptographic signature. And it has your data on there, right? It has your name, your address, all this information. Now, if you were to go to the TSA at the airport to fly out of the country, they're gonna look at that information and they're gonna say, hey, I trust this signature. It's signed by the US government. I know it's a valid passport. So therefore, I believe you are who you say you are. You must be Randall. You must live at this address. They take it on trust because they trust the signature. Does that make sense? The concept of a JSON Web Token is the exact same thing, just with JSON data. That's it. Nothing fancy, as I said. Now, let's talk about how people use JSON Web Tokens. This is how they are actually used. It's sort of interesting. So when a user logs into a website, they supply their email and password and stuff. The website is going to validate those credentials. Usually they pull the user out of a database, they check to make sure the password's valid, you know, all those things we just talked about. But then, instead of storing a session ID inside of a cookie, this is where it diverges. With tokens, you generate a JSON Web Token, and you store that inside of a cookie. And inside of that token, you store whatever data about the user you want. It could be their ID, could be their email, their first name, their last name. It could be whatever you want. And then that is stored in the cookie that the user gets, okay? So they functionally serve the exact same purpose as sessions. So when people talk about JSON Web Tokens, what they're really talking about is JSON Web Tokens versus sessions. It's a battle. Only one of the two can survive, okay? And I'm gonna tell you which one. Now, a lot of you, if you've ever used them before, you've probably read tutorials. Like if you Google JSON Web Tokens online, you read about them, people say there's all these great benefits. Like you don't need to store them as cookies because cookies are legacy technology. They say, hey, you should store them in this place called HTML local storage or session storage. And they say the reason you should do that is because you can use them like a real API. So instead of having your browser automatically send the session ID with every request, for instance, if something's stored in local storage, you have to write JavaScript code to send it to the server when you want. So people sort of like it because of that. But here's the thing. Everyone who tells you to do that is completely wrong. It's poor, bad information. You should not trust it. It's very bad. It's a pet peeve of mine, actually. There's a million websites out there that follow this pattern, and they all have done it horribly wrong. And I'll explain why. And it's not just me. In the security community, there's this thing called OWASP. Any of you heard of it? It's sort of like a, I'm trying to think of the best way to put it together. It's like a big consortium of security professionals who audit technologies. They keep track of trends in the security community, all sorts of things to help make the internet safer. And this is a direct quote from their site. It is not recommended to store any sensitive information in local storage ever. That includes like IDs for users, emails for users, passwords, like anything sensitive should not be stored there, including JSON Web Tokens that are meant to authenticate users. That makes sense, right? Okay. Now, with that out of the way, let me explain why they actually suck. So we've already covered the fact that they must be stored in cookies because otherwise they're insecure. And I can get into why afterwards. Now, because of that, we know they're serving the same exact purpose as a session ID, right? They're trying to keep some statefulness going. And so what I've done is I did two experiments. I took a session ID for a user, like I actually did this last week, and I cryptographically signed it using the same cryptographic signature function that Flask uses by default. And I measured the length of that string in bytes, okay? Then I took the Python JSON Web Token library, and I generated the most minimal possible JSON web token I could. I inserted the user ID inside of that token as one of the JSON elements. And it also came along with all the other required JSON fields of a token. So JSON web tokens, they have certain fields that are required to be there. Then I compacted that and I got that string as and then I converted that JSON web token into a string, and I compared the byte length of that. And guess what? The session one is 51 times smaller in the most conservative possible scenario. So at the bare minimum, session tokens are 51 times smaller than a JSON web token of comparable size. And that just means you're wasting bandwidth, you're wasting CPU cycles, and some other things we can get into. But JSON web tokens are not as efficient as sessions. Now, for most of you building web applications, right, a lot of the reason people like JSON web tokens is they say, well, hey, in a JSON web token, I can embed a lot more information than just a user ID. They say I can embed a user's email, their first name, their last name, information that I want to keep in a cache, basically, and not need to talk to a database to retrieve. And what I say about that is for any large site, that is completely wrong. So if any of you talk to Google engineers or Facebook engineers or any large company where they're doing massive, massive scalability problems, if you're using JSON web tokens there, scaling them, you still need to talk to a database. You need to talk to a database to revoke tokens, to manage the token signatures. There's a lot of complicated things you cannot do by following these basic principles. So for most people, you're going to be talking to a database no matter what you do. And so that is not a benefit. And again, I'll answer questions afterward. The next thing is I actually gave a talk about why JSON web tokens suck in depth for an hour a couple weeks ago. And someone came up to me afterwards and they said, hey, well, if a JSON web token is cryptographically signed, and the cookie that it's stored inside of is cryptographically signed, isn't there a security benefit there? Because it's doubly signed. And the answer to that is no. It's a bad idea. Because you wouldn't sign a letter twice. The same principle applies here. It's not really helping you out. So finally, what are JSON web tokens actually good for? They're good for as one-time usage tokens. That's their whole purpose. So if you ever see someone using them for something to persist state, you don't want to do it that way. You only want to use them as one-time usage tokens. If you read the JSON web token spec, it spells that out explicitly in there. Here's the ideal use case: password reset. So if a user tries to reset their password on a website, the website will generate a JSON web token that's valid for something like 30 minutes only, and put it in a link to an email that the user clicks to reset their password. When the user clicks that link, they're going to make a request back to the website. The website is going to parse that JSON web token out of the URL. It's going to look at it and it's going to say, hey, this is a valid token. I trust that I created it because it was signed by me. And it says that I should allow this person to reset their password. So then the website is going to validate that information and finally let the user reset his password. That's a great use case. It's happening once. There's no database involved. It's an ideal way to make use of these things. So finally, in summary, this is the end of the bonus section here. JWTs are not meant to be used for persisting state ever, especially authentication state, because they're horribly, horribly inefficient at it. Making them do the exact same thing as cookies is just less efficient and less secure. And that's the TLDR of that section. So anyways, thank you guys again. If you have questions, I'm happy to talk to you. I know it's running very late. I appreciate your time. So.